So in the last video, we talked about the first two logarithm properties, and we talked about adding and subtracting, but there's more than just that. So our third one we're going to talk about is going from a coefficient to an exponent. And we remember the vocab word coefficient, right? It's the number in front of the variable. And we remember the vocab word exponent, it's the number that the variable is raised to, okay? So in my really generic purple algebraic statement here, we have a times log base b of c equals log base b of c raised to the a. And so all this is saying is that these two statements are equivalent. So if the a is here, it's the same as though the a is up here, which is really interesting. Okay, so you can kind of think about it if you get it in this form, and this is what my high school math teacher told me, and it's like the only thing I honestly remember from Algebra 2. Thank you, Mr. Lloyd. He was like, when you have an a up in the exponent or a variable up here, then you can shake it down in front, and that's why the a moves over here. Okay, so if you have anything here being raised to something else, you take that something that it's raised to and you shake it down in front, you move it down, okay? So we're gonna look at an example, and I hope that you're equally as embarrassed by this video as I am, okay? So our example is going to start with 3 times log base 2 of 8, okay? And so we're just going to kind of prove that this is equivalent to log base 2 of 8 to the third power. Okay, we're just going to prove that they're equal. So before, a couple videos ago, we learned how to go from exponential form to logarithmic form and from logarithmic form to exponential form. So we know that this is saying 2 to the what gives me 8. And we know that 2 to the third power gives me 8. So this whole statement right there is really just equivalent to 3. So I have 3 times 3, which gives me a 9. And we want to see if this also equals 9. So this is a little tricky, okay? Because we need to figure out what 8 to the third is if we want to prove this. And so we know 8 to the second is 64. So then we have to multiply 64 by 8 one more time. So 8 times 4 is 32. 8 times 6 is 48. Plus 3, so I end up with 512. So this whole thing equals 512. Okay, so we can rewrite this whole logarithm as do it in blue, log base 2 of 512. So we need to figure out 2 to the what power gives me 512, okay? So you can use a calculator if you want to work backwards, like 2 times 2 is 4, 4 times 2 is 8, and keep going all the way up to 512. You're more than welcome to do that. But I'm going to tell you that if we know that 2 to the 8th is 256, right? That one's a little more familiar to us. Then 2 to the 9th is just 256 times 2. So 6 times 2 is 12. 5 times 2 is 10 plus 1, that's 11. 2 times 2 is 4 plus 1, that's 5. So we know that 2 to the 9th is really 512. So this also equals 512 because this is saying 2 to the what power gives me 512. And we know that power is 9. So over here, this ends up equaling 9. And over here, this ends up equaling 9. So you know that this rule works. So anytime you have a coefficient, right, you can rewrite it so that it moves up here as the exponent. And every time you have an exponent, you can rewrite it so it moves down here, shake it down in front, so it's the coefficient. So the last logarithm property that we're going to learn is called the change of base formula. It's our fourth and final one. It's really useful when you're using a calculator, kind of useful when you're expanding and condensing, but more useful when you're using a calculator. So if you look at your calculator, I don't know if you have one near you, you can even look on your phone, that also has logs on it. The usual log, when we write log like this and there's no base here, we just assume that's a 10, okay? So the only logs on your calculator are ln, which we haven't talked about yet, and the log with base 10. So if you have something with a different base, like a 2, a 3, a 17, then you can't really enter that into your calculator because it's only in base 10. So to help us with that, we have something called the change of base formula. So if I give you an example, right, and let's say we do log base 17, 357. We can't really enter that in our calculator and we don't know what that comes out to. So it's just kind of like an ugly logarithm. So what we can do instead, right, is use the change of base formula. So if this is what I start with, my purple generic expression up here, right, the 17 equates to the B, the 357 equates to the A, and the C, we're gonna make 10. So this turns into log, I'm gonna write in base 10 so we don't get confused, but if I just write log, it generally means base 10. So log base 10, 357, over log base 10 of 17. And then you would be able to enter that into your calculator and come up with a number.